Even today, women are paid less for doing the same job as men. Even today, women are overrepresented in low-paying jobs. Even a parent can do a lot to bridge the gender pay gap, and I'll tell you why. One of the reasons median salary for women is lesser is because women are underrepresented in high-paying jobs. Only 39.9% of financial analysts are women. Only 7.8% of aerospace engineers are women. In America, for example, orthopedic surgeon is the highest paying job, with an annual compensation of around $450,000. There are just 7% women in this profession. A chief revenue officer earns $400,000 a year. Only 19% women are in that field. You see, one of the problems is we often encourage young girls to pursue a certain kind of careers. While men take up STEM, humanities is seen as suitable for women. At costume parties, young girls are often princesses, young boys are astronauts. At birthday parties, girls are given Barbies, boys, robots and Legos. Yes, we give them choice, but we also shape their choice by these biases we unwittingly foster. These biases then shape our society.
There's a class at Harvard University called Math 55, which is advertised in the catalog as probably the most difficult undergraduate math course in the country. Math 55 does not look like America. Each year, as many as 50 students sign up, but at least half drop out within a few weeks. In 2006, the final roster was 45% Jewish, 18% Asian, 100% male. Well, some annoyed reader of the Harvard Crimson added, and all virgins. Well, as a rule, women tend to gravitate to fields such as education, English, psychology, biology, art history, while men are more numerous in physics, mathematics, computer science, and engineering. Why should that be? Well, there's no simple answer. But when professors were asked why there was a relative scarcity of female professors in math, science, and engineering, 1% believed that it was because of women's lack of talent. 24% believed that it was because of sexist discrimination, and 74% chalked it up to differences between men's and women's interests. According to an analysis performed by my colleague Mark Perry, for every 100 girls who score 700 points or higher on the math section of the SAT, 184 boys do the same. The SAT performance gap suggests that there may be more boys at the highest level of sexist discrimination. I mean, this is hugely popular in the women's lobby. Over the past decade or so, there has been an avalanche of literature claiming that women face hostile environments in math, tech, and engineering programs. Well, here's the first problem with all this. Why is there so much alleged discrimination in math and engineering, but not in biology, agriculture, veterinary medicine, law, where women are flourishing? There are indeed many studies that purport to show bias against women. But when anyone outside the STEM equity universe reviews them, they turn out to be flawed or sometimes shamelessly slanted. So let's turn to a third possibility, different interests. There's a lot of evidence that men and women, taken as groups, have somewhat different propensities, aspirations. Women earn more PhDs than men in the humanities, social sciences, education, life sciences. But men prevail by large numbers in engineering, physics, computer science. Does sex role stereotyping or patriarchy explain these choices? Or could it just be that in the pursuit of happiness, men and women take slightly different paths? When asked on a vocational preference test, how would you prefer to spend your time? More men than women say they would enjoy manipulating tools or taking part a machine. Women are more likely to say they'd prefer to work with people or living things. And finally, one last intriguing finding. Male and female math prodigies, they differ in a significant way. Males are more likely to have what the experts call an asymmetrical cognitive profile. That means that their proficiency at math is not accompanied by a proficiency in verbal expression. On the other hand, females who are gifted in math are often just as gifted in verbal expression, and that gives them career prospects that the gifted men don't have. So my guess is that the girls with the talent for Math 55 are just too interested in other pursuits to spend most of their week on linear algebra.
Now let's see, should I major in chemistry or galgebra?
Is feminist biology likely to contribute to our knowledge and understanding of the world? The factual feminist is skeptical. First of all, the fellowship will be monitored by the University of Wisconsin's Women's Studies Department, not the biology department. Now, when asked about why they needed feminist biology, a postdoctoral fellow who's been chosen for the program, she explained to Campus Reform that, quote, in order to do science well, she said, we can't ignore the ideas and research of people who just don't happen to be male. But wait a minute, women are hardly ignored in biology. In fact, they have far surpassed men in earning biology degrees. What is more, women are flourishing and winning Nobel Prizes in that field. So what does biology look like through the feminist prism? Well, here are a few examples. There was a feminist astronomer who argued that the phrase Big Bang Theory was off-putting to potential female astronomy students. And then, of course, there was the formidable Catherine McKinnon. She argued that the male scientific approach was similar to that of a rapist who would take joy in violating Mother Nature, penetrating her secrets. Now let's take a quick look at what some would consider to be a serious and solid achievement of feminist theory in the area of biology. And that would be the debunking of the active sperm, passive egg myth. According to feminist lore, male biologists described fertilization in terms of the macho warrior sperm invading the coy and passive egg. It took alert and clear-eyed feminist biologists to overthrow this backward sexist view. Well, was it really feminist biologists who discovered the active egg? No, that narrative is a complete myth. Scientists have known about the active egg since the 19th century. But magazines like Popular Science are still printing the feminist lore of the active egg, even though it has been definitively refuted.
A research team by Cornell University's Stephen Ceci and Wendy Williams asked why women hold less than 1/3 of tenure-track positions in math-intensive fields such as physics, chemistry, geoscience, and engineering. They examined several hundred analyses of recent data on hiring, salary, promotion, productivity, and job satisfaction. And they found that women fare as well as men in professional achievement and satisfaction in these math-intensive science fields. PhD women are as likely as men to be invited to interview for tenure-track jobs, to be offered such a job, to receive comparable salaries, be promoted to assistant professor. Their rates of grant funding are comparable with men, they work similar hours, and they express similar levels of career satisfaction. The publication rates. For women without children, the rate was the same as that of men without children. But for women with children, well, they were the least productive, while men with children were the most productive. Now, the data from childless men and childless women suggests that there are no sexist barriers to women's success. Even so, it appears that these differences in publication rate did not affect promotion to assistant professor. So if biases don't explain underrepresentation of women on the tenure track in math-intensive fields, what does? The biggest reasons, according to Ceci and Williams and others, are rooted in women's earlier educational choices, like their chosen college courses, their occupational and lifestyle preferences. When Ceci and Williams presented the highlights of their work in a New York Times op-ed, there was blowback. One science professor found the piece to contain flawed and offensive logic. Critics claimed that the authors turned a blind eye to workplace hostility, thereby overlooking the malignant forces to which women were surely subject. But think about it. If harassment and hostility were rampant in today's engineering schools, computer labs, departments, and chemistry labs, why would women's satisfaction be as high as it is? What's more, women tend to drop out of the pipeline more often than men in those fields in which women are well represented or overrepresented, namely psychology, life sciences, and the social sciences. Why might that be?
As part of our work at the Cornell Institute for Women in Science, we became interested in the topic of sex bias in hiring, and particularly whether sex bias was responsible for part of the underrepresentation of women in math-intensive fields of academic science. So this interest led us to plan and execute a national study.
Numerous blue ribbon panels, national commissions have concluded that there are a shortage of women in these math-intensive fields because of both explicit and implicit biases in the hiring process. One would have thought there would be really solid experimental and actuarial evidence of such sex bias in hiring, and we were really quite shocked in pouring through this literature, and it took us many months to digest it all, how little evidence there was, and in fact there was no experimental evidence. There were experiments, many of them, showing that there were sex biases in hiring, but not of professors, not of tenure-track professors. One thing that I think really surprised us when we started this project was, as I said, there was very little, almost no experimental evidence, but there actually was a lot of actuarial evidence that went opposite to the bias claim. By that I mean, there were a lot of very large-scale studies that looked at who got hired. And these studies, again going back to the mid-1980s, showed that over and over again, women were hired at a higher rate than their fraction of the applicant pool. So women were less likely to apply for jobs in math-intensive areas, but if they did apply, they were more likely to be interviewed and more likely to be hired. So that being the case, we wondered, well, how can people be making this claim of sexism if women were actually more likely to be hired all the way back to the mid-1980s? And some people have retorted to this by saying, well, they're more likely to have been hired because they were stronger candidates. That is to say, fewer women applied for the jobs, but of those who did apply, they were stronger. They had sort of survived this winnowing process in graduate school, and only the really strongest survived the pipeline and applied for a job. That's why we did the experiment, because in an experiment you can control for quality. So we were able to make the man and the woman identical in terms of scholarly quality. They were both described as 9.5s on a 10-point scale, which is really exceptionally strong. And we could equate that across all the various conditions. And our conclusion was that the actuarial data was very consistent with the experimental data. In both, there was this strong female preference. So again, we found this really very pronounced female preference, about 2-to-1. And there were a couple exceptions to this. One exception were male economists. Despite female economists being just like the male and female psychologists, biologists, and engineers, male economists had no preference. Statistically speaking, they were gender neutral. So the male and female candidate were preferred by them equally often.
One potential criticism of some of the components of our study is that people may respond in a socially desirable way. They may choose a woman if they're given a slate of candidates that includes one woman, because they feel a need to respond in the way that they're expected to, but that potentially when they vote in a real departmental situation, they might not vote for the woman. To evaluate this issue, we sent some of the people in our study just one candidate to evaluate, obviously either a man or a woman, and these candidates were all identically qualified with the same credentials. And what we found was when looking at one candidate, people still evaluated the woman much more positively, wanted to hire her much more often than the male candidate. She was seen with identical credentials as being more hireable than the male candidate. And we interpreted this as meaning that values of diversity had become internalized. They weren't simply triggered by comparisons of women with men, but they were internalized to the point at which an equivalently competent woman was seen as more desirable.
Looking at undergraduate enrolments in 2016-17 of students whose principal subject was physics, just 22.1% were women. And in computer science, just 17.2%. In engineering and technology, 17.6%. And in maths, just 37.1%.
People have long thought that the more gender equal a country is, the more similar boys and girls and men and women will become in their sort of like interests and occupational choices. If you ask the average person in the street, well, do you think that there are more women going into STEM in, say, Finland or Norway than in Turkey or Algeria? People will say, well, obviously Finland or Norway, because we know those are very gender equal countries. And we see the opposite. So that is a very paradoxical finding, and that is why we called this study the gender equality paradox.
Countries like Finland, Norway and Sweden measured high for gender equality but low for women STEM graduates. For countries like UAE, Tunisia, Turkey and Algeria, it was the other way round. This, by the way, is the UK.
Life satisfaction is higher in gender equal countries. And we think that when life satisfaction is higher and when people feel more secure in a society, they feel they can do what they really like. They are less driven by economic interests.
But there are other explanations offered, that women in less gender equal societies haven't been excluded from science in the past, unlike women in Europe and North America.
The only female Fields Medal winner, the Fields Medal is like the Nobel Prize of mathematics, was Maryam Mirzakhani, an Iranian-American woman. And I don't think that's a coincidence that she happened to be Iranian. Iran has very good rates of women in science. They don't have the same stereotypes for some reason as Europe does.
However, the gap in so-called STEM subjects only tells us part of the story about women studying science subjects at university. There are plenty of subjects with big gender gaps that favour women. Of undergraduates whose principal subject is medicine, 55.2% are women. In dentistry, it's 62%. In biological sciences, it's 63%. In veterinary science, it's 77.3%. And in nursing, it's 90.5%. Indeed, taken as a whole, women account for 51.5%, over half of science undergraduate enrolments.
Most subjects at university are dominated by women. There are very few areas, we mentioned engineering and computer science, that are dominated by men, but the gaps there are actually much, much smaller than for things like nursing, teaching, social work, education studies and so on. And I think it'd be much better if we concentrated in getting gender equality across all subject areas rather than just focusing narrowly on STEM.